Evaluate this integral using the trapezium rule with 4 intervals to 3 decimal places. So let's do that then. This is the first thing we need. So here, let's get the h value. b minus a, so 1 minus 0 is 1, over the number of intervals, which is 4, quarter, which we can write as 0.25 if we wish. So there's 4 intervals, so there's 5 ordinates. Let's write them down. There they are there. Oh, x4, 0 to 4 is 5 intervals, isn't it? So we just need that many there. 5 intervals, there we go. And we go from 0 to 1, and we increment the interval by 0.25s, don't we? So just keep adding on 0.25s. There we go. So there's our x ordinates. Now we need the y ordinates. So it's sine, it's easy to write, sine to the 5 of 0, which equals 0, sine to the 5 of 0.25, and again, just for 0.5, make sure we're in radians mode as we work these out on the calculator. We could have put f of x's just to save a little bit of time, but this is fine. So there's that. Now we're going to radians mode and we need sine to the power of 5. So we're in radians mode. Check that. So it's sine 0.25 bracket power 5. That should be it. So what I'm going to do, just to avoid any confusion, is I'm going to make sure I put a bracket around that. It's the whole of the thing. So I'm not going to get confused by that in any way, shape or form. So it's this object to the power 5. And the decimal, well, we get times 10 to the minus 4, so it's 0.0009, wasn't it? 1, 2, 3, 4. Let's keep going. We've got more of the number. 269, so that's fourth. So the fifth is a 2. We're doing to 5 dp, so the 6 rounds of 2 up to a 3. We're going to do these to 5 dp because the final answer needs to be to 3 dp, so this leaves sufficient margin of error. So that's what we got for the first one. Let's just check that. Times 10 to the minus 4, so if the 9 was here, minus 1, minus 2, minus 3, minus 4, so that's where the 9 is. So we just need the 3, don't we? The 2, and we round it up to a 3. Now let's do 0.5, so let's get rid of that. And this value shouldn't be quite so small. And we get 0.025 1, 2, 3, 2, so it's 0.2533, isn't it? 0.02533. Let's just check that. Yep, that's fine. And then 0.75. 0.14715. 0.14715. 14715, yeah, that's good. And then the sine of 1 radian. So let's just delete 0.75. Put a 1. 0.421889. See the 6 rounds the 8 up to a 9. 42189. 0.42189. There we go. There's all our entries then for the formula. So the integrand equals then, the integral equals h over 2, 0.25 over 2. So let's put that down, times the first and the last added together. So 0 plus this, so it's just going to be 0.42189, plus 2 times everything in between the first and the last, and then you work out the answer. So between the first and the last of these 3 entries, there's 3 entries. Let's tap them together in a calculator. So we've got 0.14715 plus 0.02533 plus 0.00093. So they were just three numbers, 00093, 02533, and 14715. 0.17341. There we go. 2 times this number then. So times that by 2. You get the number here, plus this number. You get the total for the bracket. Times it by 0.25 over 2, which is 0.125. So let's just times that then by 0.125. And there's the answer. To 3dp we've got 0.0960. So it's 096, isn't it? 0.096. And that was to 3dp.